So today we're going to be looking at SiN, the molecule, not the action. So I always like to start off by adding up the electrons of each element. So silicon has 4 electrons. Nitrogen has 5 electrons. And we can see that this is an ion, and specifically it's a -1 ion. So we're going to add an extra electron. And that's going to add up to equal 10 electrons, which is equal to 5 electron pairs. So then I'm going to draw the Lewis structure. So we put in our elements, silicon and nitrogen. And I'm going to do a triple bond, 1, 2, 3. So that takes up 3 of the 5 electron pairs that we calculated when we added up the electrons. So then we still have 2 more left, and those are going to go 1 for nitrogen and 1 for silicon. Because this is an ion, we can't forget to include the brackets along with the negative charge. So now we can see that there is a full octet. Next we can move on to the Vesper structure, which is going to look a lot similar to the Lewis structure. So we draw our silicon, we draw our nitrogen, we draw our triple bonds, our lone pairs, our bracket, our negative charge, but we also include the angle, which in this situation is 180 degrees. Therefore, the electron and molecular geometry of SiN is linear. So all of this information is just going to help us draw the contour diagram. So the next step before we get to the contour diagram is the box diagram. So I'm going to go ahead and clear out the screen of all the information except our molecule. So now we move on to the box diagram. So we're going to start first with silicon. So we know silicon has a full 3s orbital. So we add 1, 2. And we also know that normally it has 2 valence electrons. 1, 2. But we don't have a normal silicon. We have a silicon ion with a -1 charge. So we're going to add in 1 more electron. From here we can go straight to hybridization because there's nothing we need to excite. So into the sp orbital we're going to move the 3s and the first 3p electron. So we're going to have 1, 2, 3. So this is our lone pair right here. And then right here we still have 1 more spot left to bond. And this is going to be a sigma bond. These 2 electrons right here are going to go in here. And these are going to form part of our pi bonds. So now we're going to do the same for the nitrogen atom. We're going to have a full 2s orbital. And then we have 3 valence electrons in the 2p orbital. So, just like silicon, we're going to hybridize the 2s orbital and the first electron in the 2p orbital. So then we have 1, 2, 3. Just like we have 1, 2, 3 electrons. And then these 2 electrons right here are going to go right here. So then we have 1, 2. Now we're going to bring everything together. And so this is going to be a little confusing because I have it side to side. So just try to work with me and follow along. So these electrons are going to bond together to form the sigma bond. Okay? And then these are going to bond together to form the pi bonds. So it's a little messy, but once we do out the contour diagram, you're going to be able to see where everything came from. So then that's our next step. We're going to go ahead and draw the contour diagram. So I'm going to go ahead and clear the screen again so we can draw our contour diagram. Just a reminder that we have one sigma bond and two, I should have written this out, two pi bonds. Okay, 1, 2. So now onto our contour diagram. So let's start out by drawing just a straight line. And we know that on this straight line we're going to have a silicon atom and a nitrogen atom. And we know that all of this is going to have to be in brackets with a negative charge. Sorry for the spacing. So now we're going to draw in our orbitals and our bonds and everything. So first we have an sp orbital. We have it going like this. One from the silicon, right? And then we have another one coming from the nitrogen. And this is the sigma bond that they were both sharing. So let's put that it's a sigma bond here. And let's label that it's an sp orbital. We also know that each one of them has a lone pair, which is still part of the sp orbital. So we're going to draw another sp orbital here. Let's label that. Another sp orbital here. And let's label that as well. So finally, all we're missing are the pi bonds and the angles. So I'm going to draw the pi bonds in green. So there's two pi bonds. So this is one right here. And then there's another one right here. And we're going to do the same to the silicon. One here, one here. Oops, that looks like bunny ears. One here and one here. And so what we're going to do is we're going to put an electron here, an electron here, and electron here, and one here. So then this one is going to bond with this one. The inside ones will bond inside and inside. So these are our pi bonds, pi. And the overall angle of the whole thing is 180 degrees. And so this is how we get the contour diagram of a SiN molecule. Oh, before we end, let's not forget that we have to label the orbital. So this is a 2p orbital, 2p, 2p, 2p. And that is the conclusion of the SiN Lewis structure, Vesper structure, box diagram, and contour diagram.